Here is grade 7, module 7, lesson 1. I can write different forms of linear expressions to represent the same real-world situation. So here we have a word problem. A clothing store is having a sale on a particular pair of jeans. Buy 2 pairs and get a third pair for 50% off the original price. A customer wants to know how much he would pay for 3 pairs of jeans. Write an expression in 2 forms to represent this situation. So here we have, we're going to use J to represent our unknown value. So we don't know how much each pair of jeans cost, so we can't figure out how much 50% of that is either. So we're going to use J to represent and assign it as a variable to our unknown value. So we're going to use J to represent our jeans. And then we need to write an expression that would result in the total cost using addition. This is the first form to represent the situation. So we have J, this is our first pair, our second pair, and then our third pair is half off. So times 1/2 or times 0.5. This right here is one way to represent or to write an expression. And then our other form is to combine those like terms. So just a refresher, if nothing is in front of your variable, it's a 1. So if we take all of our coefficients here, 1 plus 1 plus 0.5, we would get 2.5. And then we have to make sure we bring our variable along. So that'll get us that 2.5J. So what's in the green there are the 2 answers that they're looking for. Until you know the value of your jeans, of J, you cannot simplify those any further. All right, so we have a plumber that charges a rate of $65 per hour for his time, but gives a discount of $7 per hour to senior citizens. Write an expression that represents a senior citizen's total cost for the plumber in 2 different ways. So we have a plumber charges $65 an hour, so that's their rate, and then we have a discount of $7. Okay, we have a discount of $7. So we have, per hour. So not a flat rate, or not a flat discount, but a discount per hour. So for everyone who is not a senior citizen, you would have $65 per hour. But we get a discount. So we are going to be subtracting that rate. $7 per hour. So, and again, we can't simplify that any further unless we know how many hours he was at the house. If he was there for 2 hours, we would take a 2 and plug that in everywhere where we see an H. But we don't know right now. So that is one of the ways we could write an expression. And then the other way would be to, just like we did here, take our coefficients, and here we're going to be subtracting. So 65 minus 7 will give us 58. So the other way we could write this is 58H. Okay, so there are our 2 ways, 58H, and then 65H minus 7H. Again, don't simplify any further until you know how many hours, for this example, how many hours he is at the house. For number 2, a restaurant offers a lunch special for $15 plus a $3 tip for the server. Write an expression that represents the total cost for this special in 2 different ways. So it's going to be $15 per person plus a $3 tip per person. So we have $15, and we're going to use M for the per person part. So we're going to have 15m plus 3m. So this is for your food. And here is your tip. Okay, we always add those together. So you always have to pay for the cost of your food and then add whatever that tip is. So again, that's as simplified as we get. 15m, your cost for the food, plus 3m. So if you were to know how many people came, you could plug in, say we did 5 people. 15 times 5 plus 3 times 5. Okay, but we don't know that yet. And then what would be the other way to do that? Because we do need to do this 2 different ways. Pause the video if you need to, but what's the other way we're going to write that? Okay, you can always look at our other examples, because our other way is to look at our coefficients, 15 plus 3. Our other way would be to add those together to be 18m.